Okay, so let us find the inverse of the matrices, which is given here. A is equal to IA. Now we know what is A, 2, 1, 1, 1. Okay, which is equal to I, which is 1, 0, 0, 1.
So 0,
Okay,
1, 1.
and this is A. Now applying R1, R1 minus R2. Okay, let us apply this. So after applying this, we get this. Okay. Now again
Yes, sir.
applying the row operations. So we'll continue. Again applying for the row 2. Okay. So hence we got A inverse as 1 minus 1 minus 1, 2. So this is the inverse of matrix A. So we will find the inverse of this. Okay. Again, you know what is this? So this is A. So A is equal to I plus A. So this is 1, 3, 2, 7, which is equal to 1, 0, 0, 1.
0, 1.
Let's apply the row operations. Okay. So first is 1, 3. Okay. So this will be 0 and this will be 1 after applying it. Okay. Now again for the row operations in the right hand side, 1, 0. Now this will be minus 2 and 1. Okay. So on the rows, row 1. So what do we get? 1, 0, 0, 1, which is equal to 7 minus 3 and minus 2 and 1. So I'm operating on the row 1, which we get like this. So we got this as I now. So this will be A inverse will be 7 minus 3
Minus 3.
minus 2
Minus 2, 1.
1. Okay. So this is the inverse of the given matrix. We'll discuss on determinants. Okay. So till now what we have learned on the matrices and the algebra of matrices and the system of algebraic equations, which was in the form of matrices. So we had like a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2, which can be represented in a matrix form, that is a1 b1 a2 b2. Okay, so x and y, okay, which is equal to c1 and c2. Okay, Now, this system of equation has a unique solution or not is determined by the number, that is a1 b2 minus a2 b1. Okay, so that is a1 by a2 is not equal to b1 by b2, or a1 b2 minus a2 b1 is not equal to 0. Then the system of a linear equation has an unique solution. Okay, so which determines the unique of the solution is associated with the matrix as A. Okay, so this is as a matrix as A. Okay, so and is called the determinant of A or det A. Determinant of A or det A. Okay. So determinants have a wide applications in engineering, science, economics, social science, etc. Okay. So here will be fine. Yeah. Let us evaluate this. Okay. So this becomes 2 multiplied 2. Okay. And minus 4 multiplied minus 1. So we have used here multiplying it and simplifying it. So we get this as 8. Okay. So this is the determinant. So this will be, yeah,
X.
x into x, right? Minus
Yes.
x plus 1
X.
and x minus 1. Okay. So after simplifying x square, this is minus, this will be x square minus 1. Okay. So you get 1 after simplifying. Just find the determinant of this. So this will be so taking this, right, and also 0, 1, 2, 4, 1, and plus 0, 1, 2, minus 1, 2. After that, we have to find the individual one. So 4, and this becomes 0. This also becomes 0. So we get this as minus 1 and minus 12. Okay, so we get this as minus 52 after simplifying. Okay, let us find or evaluate the determinant of this. Okay. Yes, we are looking into the row 1 now. We will put this minus again here, and this will be sine alpha, and corresponding to that will be minus sine alpha 0 and cos alpha minus sine beta plus now this will change the sign. Okay, so
Yes.
if I put that as minus, so let us put that as minus
Yes.
cos alpha. Okay, so minus right. Okay, now let us find the determinant. Okay, and then for that sine beta minus 0. Okay, so now if we look to further simplify this, you get sine alpha, sine beta, cos alpha, and this will be minus cos alpha, sine alpha, sine beta. So if you look at this, these two are same, right? But and then again sign. Okay, so that results to 0. So the determinant will be 0 for this. Let us solve this. We'll find the value of x for which this matrix is given. So for this, we have equated this. Now let us find the determinant of this and determinant of this. So this will be 3 minus x square. Okay, and this will be 3 minus 8. So you get x square as 8 or x as plus or minus 2. So this is the value of x here. Okay, I'll find the determinant of this. So this will be cos square theta minus minus of minus will be plus. So that will be, or you can put this afterwards. So minus sine theta, and this is sine theta. Okay. So this will be
Yes.
cos square theta plus sine square theta. Okay, which is nothing but 1. Okay,
1.
so that's it.
Yes.
This will be x square minus x plus 1, x plus 1, minus x minus 1, and x plus 1. Yeah, and you can cancel out these one. So final answer will be x
Q.
cube minus x square. Now this is plus 1 and this will be plus 1. So this will be plus. So this will be the determinant of the graph problem.